As you may recall, I've been sharing snippets from a neuroscience course I audited through Harvard. Here's a summary of the anatomy of the visual system. The visual system is a complex network of structures that work together to detect and interpret light, allowing us to perceive and understand the world around us. We'll explore the ventral and dorsal pathways, two crucial components of the visual system. Let's first look at the ventral pathway, the what pathway. This pathway is responsible for object recognition and identification, processing information about shape, color, and texture, projects to the temporal lobe, specifically the inferior temporal gyrus. Then the dorsal pathway, the where pathway. The dorsal pathway is responsible for spatial awareness and object location. It processes information about motion, depth, and spatial relationships. It projects to the parietal lobe, specifically the lateral intraparietal area. So you've learned today that the ventral and dorsal pathways work together to provide a comprehensive understanding of the visual world around us. The ventral pathway helps us identify what we are seeing, while the dorsal pathway helps us understand where it is in space. Here's a summary from the Harvard Neuroscience program.
That was a lot of information, so let's do a quick review. Once the visual information from your eyes reaches the back of the brain, it's processed in two pathways, the ventral and the dorsal. The ventral pathway is called the what pathway, and it identifies objects. In this pathway, information flows from area V1 to V2 to V4 to IT. The receptive field size and complexity of information being processed increases as you step through each of these areas. Lesions in V1 or V2, called scotomas, cause localized blind spots. But lesions in IT have more complicated effects, called agnosias, or problems with object recognition. An example is prosopagnosia, or face blindness. Now, let's review the dorsal pathway. The dorsal pathway is often called the where or how pathway and identifies where an object is in space and how we might interact with it. Some areas of interest in the dorsal pathway are MT, which detects direction of motion, and PPA, which is responsible for spatial attention. Lesions in both of these areas can have complicated effects. In MT, lesions result in akinetopsia, or the inability to detect motion. Affected patients see the world as a series of snapshots. In PPA, a unilateral lesion causes visual neglect, where the patient does not perceive part of the world. Bilateral lesions in PPA cause Balint syndrome. One symptom of Balint syndrome, simultagnosia, causes the patient to see the world one piece at a time, rather than as a cohesive whole. For example, a patient might see a refrigerator or a stove, but cannot direct attention to both at the same time and cannot see the kitchen as a whole. So we've seen how pieces of visual information are sent to different places in the brain for processing, and how damage to the brain can consequently alter perception. But now that that information about what and how and where is scattered between the dorsal and ventral pathways, how do we get it all back together so we can interpret a scene?
Science is so exciting. Isn't it interesting to learn how your body functions and to now fully understand your senses, seeing, hearing, feeling, tasting, smelling? Let me know in the chat how you are enjoying this program.